and welcome to Dr. G's Technique of the Week, Precalculus Edition.
Today we're going to apply exponential and logarithmic equations to some applications, in particular applications in finance and in medicine. So to start off, let's consider this situation where you have invested $8,000 into a bonds fund, and this fund has an expected yield of 4.5% that's reinvested monthly. In other words, each month you are earning interest of a sort at a rate of 4.5% reinvested each month. And we want to know how long it's going to take for your investment to double to $16,000. So as a first step, let's write down the formula for interest compounded monthly and input into that our principal investment of $8,000 with our expected yield rate of 4.5%, just like we would with an interest rate. That will give us the amount in this account equal to the principal investment times 1 plus the yield rate over the number of times per year this is reinvested into the account, to the power of that number times the number of years that this account is sitting there and gaining extra money. So our initial investment, our principal investment, is $8,000, and our yield rate is expected to be about 0.045, and it's going to be reinvested monthly, so 12 times a year. So this is our equation then for the amount that we have. And we want to know when it will double, which means that our amount is going to be $16,000. So now what we need to find, since we want to know how long this will take, is t. So we want to solve this equation for t. So to start out, we need to isolate the exponential on one side of the equation. We can isolate the exponential by dividing both sides by 8,000, which will give us 2 equal to 1 plus 0.045 over 12 to the power of 12t. And now to get this t out of the exponent, we can take the log of both sides. Let's use the natural log, although it doesn't actually matter what logarithm you use, what base logarithm. Now use the power law for logarithms to bring down this exponent. Remembering that the power rule takes the exponent outside of this log and pops it out into the front to be multiplied onto the front. So we'll get the natural log of 2 equal to 12t times the natural log of 1 plus 0.045 over 12. And if I want to solve for t now, I can just divide both sides by 12 and also divide both sides by a natural log of 1 plus 0.045 over 12 to isolate t all by itself on one side of the equation. So that'll give me the natural log of 2 divided by 12 times the natural log of 1 plus 0.045 over 12. And this is something that then we can evaluate with a scientific calculator and find that this is going to take approximately 15.4 years for this investment to double in size. Now let's consider the case of the sound at a concert. And suppose we know that it's 124 decibels, the loudness of the music, and we want to know, will it be painful? Will it physically hurt to hear music this loud? So some information that we know from experiments is that we can model the loudness as 10 times the log of the intensity over a base level intensity, and that base level intensity has been found to be 10 to the negative 12 watts per square meter. And we also know that it is painful for humans to listen to a sound whose intensity is greater than or equal to 1 watt per square meter. So to start off, we need to just substitute in our loudness of 124 decibels and the base level intensity I naught of 10 to the negative 12. This will give us an equation of 124 equal to 10 times the log of I over 10 to the negative 12, where I is the intensity of sound at this particular concert with a loudness of 124 decibels. And so we need to solve this for I. So the first step in solving a logarithmic equation like this is to isolate the logarithm by itself on one side of the equation. We can do that by dividing both sides by 10. So we'll have 12.4 equal the log of I over 10 to the negative 12. And then we can get rid of the logarithm by rewriting this in exponential form. So in exponential form, we have a log base 10. So we'll have 10 to the 12.4 equal to the input of the logarithm, which is our intensity, over 10 to the negative 12. And multiplying both sides by 10 to the negative 12, we'll get that our intensity is 10 to the 12.4 times 10 to the negative 12. Adding our exponents together, the product rule for exponents gives us 10 to the 0.4, which is approximately 2.5 watts per square meter, which is a whole lot bigger than 1, so this is going to be really painful to listen to.
Now it's time for you to get some practice with these new ideas. See you next time on Dr. G's Technique of the Week.